Right, hi everybody, welcome back again. We'll continue in this video with topic 2.2. As we know, topic 2.2 is communities and ecosystems. In the first video, I looked at flow of energy through ecosystems. And in this one, we're more concerned with the graphical representation of that flow of energy, or the amount of energy, or we could say the amount of biomass through the ecosystem. As you can see above my head, there's three types of graphical representation or ecological pyramid. We could choose to look at a pyramid of numbers, where we simply count individuals and show that graphically. We could show a pyramid of biomass, or perhaps energy, depending on which units we decide to use. I'll look at those units in a minute. And then finally, the most useful type of pyramid, and the one we'll see more than any other, is a pyramid of productivity. Productivity is a measurement of production of biomass over a certain amount of time. So as you can see, the first two types are kind of snapshots, and that's basically the reason why they're not useful in terms of describing an ecosystem. The third one, pyramid of productivity, is much more useful because it's not really a snapshot. It takes into consideration a longer time period, usually over a year or years. Okay, I don't want to spend too much time on this, so I'm very quickly going to go to the syllabus statements. It looks like quite a lot, but it is quite repetitious. And for that reason, I don't want to read through each of the statements. But of course, you can pause this video at this point and maybe just look through them individually. So first of all, some definitions, I guess. We need to look at what trophic levels are. Trophic basically means feeding. So trophic levels are different feeding levels. Basically what feeds on what. We need to look at producers, or the autotrophs. Troph feeding, auto self, so self-feeding organisms. Basically these are the plants. So we looked at photosynthesis as a process of producing food or glucose. In the last video, I also touched very briefly on chemosynthesis, which is a very rare type of bacteria which is able to produce its own food, not by using light from the sun, but using energy from chemical bonds in certain molecules. Okay, worth pointing out here, we also have the heterotrophs. Hetero, other, troph, feeding, so feeding on others. So these are the carnivores and the herbivores. And then the last part here, or the last 4 or 5 statements, basically are concerned with what are ecological pyramids, how we construct them and what units we use, and what kind of shapes we expect. The shapes we expect basically are driven by the laws of thermodynamics. At each trophic level, as I already mentioned in a previous video, we should have less and less energy available. So therefore, diminishing amounts of biomass in each trophic level, basically. Okay, so as I said, if you want to pause that and go through the statements, you can. I won't read through them individually now. Here's these definitions again. First of all, the producers, the plants, algae, and cyanobacteria that are able to use sunlight to produce their own food in the form of glucose. We refer to them as autotrophs, or more specifically, photoautotrophs, using light to make food. That doesn't include the chemoautotrophs, or the chemosynthetic bacteria. Then we have the consumers, or the heterotrophs. These are living things that are not able to use photosynthesis or chemosynthesis to produce their own food, and therefore referred to as heterotrophs, feeding on others. And then finally, the decomposers. The decomposers are the bacteria and the fungi that feed on dead material and therefore are responsible for recycling nutrients back into an ecosystem. Without the existence of the decomposers, life on Earth would have become extinct millions or billions of years ago, because there would have been no way of recycling used nutrients back into ecosystems. So very, very important. Okay, I'm sure you're kind of familiar with this. This is a very simple food web. A food web shows feeding relationships between living things within an ecosystem. It's tempting to think of the arrows as showing what feeds on what, but technically what the arrows show is the movement of energy from one organism to another organism through the trophic levels. Hence the direction of the arrows, in this case upwards, in terms of increasing trophic level. This is quite nicely set out because it has the trophic levels basically in horizontal lines. The bottom we have the autotrophs, in this case the photoautotrophs, primary consumers, those that feed on the autotrophs, and then secondary consumers, and so on. Okay, that's a food web. And again, technically, we should begin every food web with the source of the energy, which in this case will be sunlight. And we generally don't, but you should bear that in mind. We could take one single branch of this food web, and that would represent a food chain. So a food chain is just one branch or one section of a food web. So I'll pick one at random here, and I'll draw the lines, the food chain going upwards in the same way the food web is. So we would begin with the autotrophs. So I could choose grass. Energy moves from the grass perhaps to insects, and then energy would move from insects to frog perhaps, and from frog to owl. In this case, the owl represents the top predator or the top trophic level. You can see that within this food chain, within this food web, you've got food chains of differing lengths. I could, for example, go from grass to mouse to fox. But it does actually show a parasite there as well, a parasitic tick. And it's also interesting that you can also get animals that exist sometimes in more than one trophic level. It's quite simplistic to think of a food web as just a collection of individual food chains. Okay, so that's the difference between a food web and a food chain. Now we can consider how we represent numbers, biomass, or productivity in terms of a ecological pyramid. Okay, so first of all, we can consider pyramids of numbers. As the name suggests, to construct a pyramid of numbers, you simply go out and you count the number of individuals within your ecosystem, within your defined ecosystem, and then you represent those as kind of a graph in which the size of a bar represents the numbers that you actually counted. It's somewhat useless, I think, a pyramid of numbers. First of all, should something like a tree really count as one individual? And if you could consider a tree or maybe grass plants, is one blade of grass really equivalent in a food web to one tree? That's one problem. The second problem with the pyramid of numbers, it's done over a very short time period, less than a day, I would suggest, and therefore it's just a snapshot of that ecosystem, a very limited snapshot in terms of time. Over time, you have migratory animals, you have movements, even of plants, and you have very different conditions from one time to the next. So therefore, a pyramid of numbers is not usually that useful. It's a snapshot. It doesn't really show you much. Yeah. They can have all kinds of funny shapes for the reasons I've just said. If you perhaps count one blade of grass to be equivalent to a tree, you can have some very funny shaped ecological pyramids. Okay, so then you might think that perhaps we could produce a pyramid that's more useful, and certainly a pyramid of biomass is more useful. In terms of biomass, you would measure that in terms of kilograms per meter squared, or if you're measuring the amount of energy available within that biomass, you could measure joules per square meter of availability. Technically, measuring in joules makes it a pyramid of energy, but we can still refer to it as biomass. Again, like the pyramid of numbers, it's a snapshot. It might be useful to look at different pyramids of biomass over different time periods, so you can see how the biomass stock changes. But it is just a limited snapshot, and it's very dependent, therefore, on conditions on that one time where you took those measurements. Biomass, by the way, biomass usually is measured in terms of dry mass. One problem with measuring biomass is that it can include a lot of water. You don't really want to measure water as being representative of biomass. So you'd normally put your biomass, including animals in some cases, into an oven, hopefully euthanized first, and you would dry them out to constant mass. So you dry it very, very slowly until you've lost all of the water. So you know you're only basically counting biomass and not water in your measurements. Again, because they're a snapshot, they're very often not pyramid shaped. So pyramid can be a bit of a misnomer here. They can be all kinds of funny shapes, as we'll see in a minute. So therefore, we come to the final type of pyramid, which will be a pyramid of productivity, which I would suggest is the most useful. The units of productivity are kilograms per square meter per year, usually, or if you're looking at energy, perhaps joules per square meter per year. So basically, this is an overall, not a snapshot, but an overall big picture of the biomass available per unit time over a long period of time. That's why I refer to it as productivity rather than biomass. Because of this, you always have a pyramid-shaped pyramid of productivity. And the reason that happens is because of the laws of thermodynamics. We know if you average out our issues with snapshots before, you always have less energy available from trophic level to trophic level to trophic level. And that's always representative in the shape of a pyramid of productivity. Okay, hope that made sense. Just to finish with some pictures of these, what you might expect to see. I won't go through them individually, but you can see on the screen, here you've got 3 different food chains and what you might expect those pyramids to look like. Here you've got these funny shaped pyramids of numbers, as I explained before. And although the biomass pyramids here are pyramid shaped, they might not always be pyramid shaped depending on the issues caused by your snapshot of collecting data. Okay, hope that was useful. I don't want to go into more detail because I want to do some exercises in the classroom based on this, but I hope that was a nice introduction to ecological pyramids, how they're constructed and what they actually show. I actually don't think there was much complicated information there, so I hope it made a fair amount of sense. All right, thanks everybody. Speak to you in the classroom. Take care.